3.2, implicit differentiation. This is an implicit relation. It's not a function. It's a relation. All right, because if you do the vertical line test to the picture of this, it fails. Implicits tend to have x's and y's all over the place. All right, they don't have y equals. Those are explicit. Explicit are y equals or f of x equals. This is not in that format. So to take the derivative of this, you just take the derivative of everything where it lies. So we're going to first take the derivative of this. So the derivative of 3y squared is going to be 6y, but chain rule, you have to take it times the derivative of y. So I'm going to write it as y prime. Now you could write it as dy dx. I'm going to write it as y prime because there's a chain rule. Because the derivative of y, the derivative of y is actually dy dx, or y prime. So there is a chain rule effect on this y, because when you take derivatives, you're taking derivatives in respect to x, not in respect to y. It's important. So, like for instance, when you take the derivative of this one, this one's a little different. Watch this. When I take the derivative of that piece, this is going to be negative 2x, the derivative of x. But the derivative of x is 1. That's why there's no extra piece. Because think about it. What is the derivative of x? Well, isn't that just going to be dx over dx, which is 1? If you think about that, it kind of makes sense. That the derivative of x is 1. But the derivative of y is dy dx, or y prime. All right? And then the last piece, the derivative of the 1 is 0. So I just took the derivative of each piece where it sits. Now my goal is I want dy dx, or y prime. So I got to get y prime by itself. So all I got to do is start doing algebra. I'm going to start doing algebra and moving things over. So I'm going to add the 2x over here. I now have 6y times y prime equal 2x. All right, still got to get the y prime by itself, so I'm going to divide by 6y. So I now have y prime, or dy dx, is equal to x over 3y. I reduced. And that is the derivative of this implicit relation. All right, let's take the derivative of this implicit relation. So the first piece, let's do secant. Secant is going to be secant y times tangent y. Okay, but don't forget your y prime. All right, people forget that all the time. Now next, I have a negative in front, so be careful. And I'm going to take this negative 3x and just leave that out front. That's the way I'm going to try it this time. Let me put a bracket there, actually. And then to take the derivative of xy, that's going to be 1 for x, leave the y, plus leave the x, take the derivative of y. All right, so that would be that whole xy piece. And that's equal to, the derivative of e to the y is e to the y times y prime. And the derivative of 1 is just 0. So that's gone. So my goal now is to get y primes to one side. That's how we do implicits. So as we do that, I'm going to actually first distribute this negative 3 here. So I have secant y times tangent y. I'm going to bring the y prime out front just because I want to. Minus 3y minus 3xy prime equals y prime e to the y. I'm going to bring the y prime out there too in front. So I want all the y primes on one side. So when I do that, I'm going to add the 3y over. And I'm also going to minus this y prime e to the y over here. I'm just going to put it over here, y prime e to the y. I'm going to put that over there, so that's gone. So what this all cleans up kind of weirdly, but it cleans up to be, this is secant y, tangent y. I have a negative 3xy prime and a negative y prime e to the y, and that's all equal to the 3y over here. Okay, so I did all that. Now our goal is to pull out a GCF of y prime, so I'm going to pull my y prime out. When I do that, I have secant y, tangent y, and then I have a minus 3x, and then a minus e to the y. That equals the 3 to the y still. And then once we pull the y prime out, the last piece we usually do is divide all the extra baggage over. So I'm going to divide each side by that huge amount of baggage. So secant y, tangent y, minus 3x minus e to the y. Okay, a lot of writing here. Sorry about that. It does take a while to write all this. I get it. It's kind of obnoxious. I know. Sorry. That's all gone. So my y prime answer, or dy dx, is equal to simply 3y on top, but you have this obnoxious big old thing on the bottom. I rewrite it again and again and again. I always hate rewriting things. And that right there would be your derivative for this implicit relation. So let's take the derivative of this. You might say, oh, it's explicit. No, I know it's y equals, but isn't there a y there too? This is not explicit because there's a y over here. Even though it's y equals, there's another y. So it's not explicit, it's implicit. So here we go. Let's take the derivative of y, which is going to be y prime. All right? Let's now take the derivative of this, which the derivative of that is a chain rule. Okay? What it's going to be becomes 1 over the inside times the derivative of the inside, which would be 3y prime minus 1. Probably want parentheses around that. And that is done, except it's not y prime. We need to get it equal to y prime. So that is the derivative. That is the derivative. We're done. Okay, so let's clean this up. Let's think of something. First of all, let's just put 3y prime 1 over 3y minus x. Let's rewrite it like that and push it over. Now, if I want to get all the y primes to one side, there are different ways of doing that. All right? There are different ways of getting all the y primes to one side. What I'm going to do here is I'm going to think about, I'm going to multiply both sides by, okay, I'm going to multiply both sides by the 3y minus x for now. Okay, when I do that, that's gone. I have y prime times 3y minus x equals 3y prime minus 1. Are we okay so far? All right. So what do we do next? Well, next, what could we do? Well, could we simply, I like this. Could we simply minus the 3y prime over? And I now have y prime times 3y minus x minus 3y prime equals negative 1. Okay. Now, can I pull a y prime GCF out? This is weird, but if I pull a y prime GCF out, that leaves you 3y minus x and a minus 3. All right. So let me move that up, and let me clean it up, move it up, and clean it up a little bit. So I'm going to move it up here. So I want that to become y prime, and want that be 3y minus x minus 3 equals negative 1. And then could I divide by 3y minus x minus 3? That's gone. So I have my answer. Y prime equals negative 1 over 3y minus x minus 3. And that would be your answer.